Imagine if you're one of the drivers in the world race, more specifically one of the wave rippers or road beasts, staring into a large alien wheel that blocks your path. Imagine if someone had figured out the specific speed you needed to go to get past this huge wheel. You would have to trust them with your life, and that's what bothered me. Somehow Lani had figured out the exact speed you needed to be at to not die at the hands of a giant spinning wheel, even though there were so many variables like projectile motion and how fast the wheels are going. And since I've done physics in the past myself, I took it upon myself to figure out if Lani was actually correct. So hopefully this video isn't boring because I'm doing calculations. I mean, all my videos are boring, but anyway, hopefully it's not boring because I put a lot of effort into these calculations and stuff. I don't even do physics anymore, and I'm still doing physics calculations. Now, that's kind of cringe. But with that being said, I've tried to simplify things into normal people terms. And let's get into the calculation. So we know the wheel rotates, and we need to avoid these three objects. Now these three objects pass the same spot every 1.2 seconds, which means we need to clear the width of the wheel in 1.2 seconds. Now not only that, we need to clear the width of the wheel plus our car length of the wheel. Now as we can see in the diagram, in this first diagram right here, if we clear just the width of the wheel, as we can see here, here is the start of the clearance, here is the end of the clearance. If we just clear the width of the wheel, we're not clearing the wheel, as each rotary object will hit our car inside here, which means we die, if that makes sense. As our car is not actually here, it's actually inside, and all we've done is, cleared the inside distance of the wheel. What we actually need to do is clear the width of the wheel plus our car length, which means we can actually get past the width of the wheel and we are alive, if this makes sense at all, okay? Just look at these images. If we clear the width of the wheel, we're still stuck in the wheel because we haven't cleared the back of our car, if that makes sense. Now, looking at Skeet's clearance of the wheel, it gives us a pretty good indicator of the length of the wheel, because look at this image, okay? We can fit 5 Skeet cars within the wheel. Now, Skeet's car is comparable to Lani's car, the 55 Chevy Nomad, which is 5 meters. I looked it up here. It's on Google. Google's always right. The 55 Chevy Nomad is 5 meters, and we can fit around 4 of Skeet's car within the width of the wheel, which means the wheel is around 20 meters, and that means adding our car length, we need to clear 25 meters. Now, taking all this into account and taking the time we needed to clear it in before, we go 25 meters divided by 1.2 seconds, which gives us the speed in meters per second, which is 20.833 meters per second. This equates to 46.6 miles per hour, which is, way off what Lani calculated, which is 163 miles per hour. Now, Lani could be right, I could be right also, but there's a massive disparity in these calculations. Now, I would assume that it would be in between these calculated values, mainly because, horizontal motion, we need to clear the whole jump instead of just the wheel. If we don't have enough speed to clear the whole jump, then we just die because gravity pulls us down. So if we have a higher speed, then we can clear the whole thing and blah blah blah. Say if we were just going at 46 miles per hour, this is what would happen. We would just fall down and die because gravity pulls us down before we can clear the jump. So we need a faster speed. Now, I don't think it's Lani's calculated value because that's just way too fast. And I think it's just somewhere in between Lani's value and my value, if this makes any sense at all. However, after looking at Skeet's actual clip, using the same process of division and stuff, the calculated value of Skeet's speed in his jump was 1,118.47 miles per hour. Holy crud, that is way off this and this. That is way off 163 miles per hour. And I can actually prove it to you. Skeet takes about 0.05 seconds to clear the thing, and it's 25 meters, so taking all that into account, you know, I think it's around 500 meters per second, and that translates to that. So Skeet was going insanely faster than what Lani said to go, and taking all this into account, Mattel does not know how to do physics animations or anything. They don't know physics at all. They just mess up the entire physics in this scene. And please let me know if this made sense at all, because, you know, I take the feedback and for future videos. And what are your thoughts? Are there any calculations you want me to do to prove if it's correct, right or wrong? And anyway, thank you so much for watching.